All right, I have the adjustment procedure. Step 1, adjust the 20-volt supply. It's to 1%. Wow. So that's 0.2 volts. And yeah, we're probably okay, but I'm going to tweak it anyway. It is way down on the other side there. Okay, so if I can adjust this, there we go. 19, 20. Okay, how about that? Looks pretty good to me. All right, check power supply voltages. Now, it should mirror to the -20, so we'll go to the -20 here. Make sure it is. And yes, perfect. All right. Now we need to go to plus and minus 17 and make sure they are okay. Plus 17's down here. 1706 and 1699. I think those are fine. They need to be within 2% of each other. Yep, no problem. Okay, so check power supply ripple. I've already sort of done that before, using a differential 1 millivolt, blah, 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 blah. Check the ripples less than 500 microvolts. Okay, well, let's see here. Set the multiplier. Okay, so set the multiplier to -1. Okay, -1. It's way down there. -1 hertz. Wow. Okay. Frequency dial to 0.1. Oh, so you can make it basically you make it do DC. Doing this. Using a differential amplifier in the oscilloscope, set the vertical sensitivity to 1 millivolt and set both inputs for AC coupling. Using a ×1 probe, connect the other in turn to the plus. Okay, so you just look at those, all those things we just looked at. Okay, we are on, let me put my ground back on. And we can just go to AC millivolts. We're looking at really small, 0.01 millivolts. Yeah, certainly less than 500 microvolts. And then we can check the other supplies. You don't have to follow. You don't need an oscilloscope. You just need a really, really good DVM. And yeah, we're really, really good there. Look at the other ones. And yep. And the other ones here, I'm sure they're all the same. Yep, perfectly fine. Perfectly fine. Ripple's great. All right. Now, adjust waveform symmetry. Connect. Okay, we need an oscilloscope for this. Connect the function generator up through a 50 ohm load to the oscilloscope input. Adjust the FG502 for approximately 10 kilohertz square wave. Okay, 10 kilohertz is up here. 10 kilohertz square wave. Should be that one there. Let's wait for the oscilloscope to warm up. All right, we need 5 volt maximum amplitude. There we go. And come out. And we should have a 50% duty cycle by eye. Okay, they want you to do this by eye, but since we have fancy equipment here, we can add a horizontal period, rise time, width, duty cycle. We are getting 50.375 duty cycle. That's pretty darn close. How much do they want you to? I mean, you couldn't do much better than I, but we can have a tweaker here. Set the oscilloscope to show blah blah blah. Adjust R170 sim. Okay, R sim. Sine drive symmetry. R. What was it? R170. Oh, way up there. Okay. Okay. R170 is down over here. Nope, nope. Even farther down. Oh, it's that one. Okay. All right. So, just so you can watch me. The way down under here is a 10-turn pot, which I will adjust. 49,997, 50, 998, 50. All right, there we go. 50.003. Close enough. Okay, so we have now symmetry. Now we need to do sine wave distortion. Okay, we can use my distortion analyzer. Let's get him going. Okay, let's see if I can minimize this one. 2%, 0.1, 0.0, 0.08. Okay, 0.8 was as good as I got. So put it there and I'll adjust the other one. See if I can make that one better. Oh yeah, a little bit. Now it's going up. Now it's going down. Okay, now it's going down. We'll leave it there, just the other one. These things are interactive, so you need to go back and forth and back and forth. 0.3, point up. 0.5, 0.4, 0.3, 0.2, there we go. Oops. These potentiometers are a bit touchy. 0.27, I'm going to adjust the other one. 9, up 1, that's better, 1.8. Okay, I think that's about as good as it's going to get. And let's validate it again with the oscilloscope. Make sure that does in fact look pretty. Yes, indeed, that looks like a sine wave to me. Okay, so we're at what, less than 0.2% distortion. That looks great. Okay, now we get to adjust triangle waves. So set to triangle. Set the frequency dial to 0.1 and the frequency, adjust oscilloscope. Okay. For linear slopes. We're looking for linear slopes, and those look linear to me, so I would say we're probably okay. Let's do different frequencies here. Yeah, I would say we're okay there. Okay, adjust low frequency timing. Connect the count to a counter. This has a good counter built into it. With 50, okay, set the multiplier knob to 10 to the 3. And the frequency dial to 11. This one goes to 11. Okay, to 11. Okay. The amplitude control fully clockwise. It is. And the frequency vernier dial to the cal position. It is. All right. And adjust R105 for counted frequency of 11 kilohertz. And currently we're at 10.79. So which one do we adjust? Times 10. Which one are we doing time? Okay. It's this one here. All right. Oh, there we go. 9, oh, so I overshot. Okay. Whoop, whoop, whoop. 10, 9, oh, there we go. Okay, 11.004. That sounds good to me. All right, now set the frequency dial to 1. Okay, and now we adjust the ×1 knob for 1 kilohertz. So this one. Now we set it to 1 kilohertz. Oh, oops, too far. Okay, 1.004. And then repeat. Let's go back to 11 and see if it's off. It will be because these interact with one another. Okay, there's 11. Oh, 11.04. Oh, that's pretty good. Yeah, that's close enough for this thing. Let's go back to 1. And we're at 99. Let's just do ×1 again. .008. And yeah, that's good. Let's go back to 1. Yeah, I like that. Okay. Adjust high frequency timing. Set the knob times 10 to the 6th and the frequency dial to 10. 10 to the 7th. Okay. And let's see here. Sine wave, all right. 10. Okay. Adjust. Wait a minute. Oh, dial to 11. Dial to 11. Okay, it should be measuring 11 up there, 1.1. Wait a minute. 1.1 megahertz. 10 to that. Change the multiplier. Oh, wait a minute. Different. Oh, okay. Like I said, there's 2 different models of the thing. I have to read the instructions for the newer one. It is dialed to 10. Okay, and then adjust C162, low dial top range for 10 megahertz. Okay, where is C12, low dial top range? Low dial top range is that one there. Okay, that's that here. It is a capacitor that I'm changing. All right, let's see if we can get 10. Oh, that's a little farther. Okay, let's see if it goes 11. Or do we get 11 megahertz? And almost. Or greater. Okay, let's adjust it just a tiny bit. Take it just past 11. Oop. 10.99, let's go back to 10. Yeah, that looks good. All right. So check the timing accuracy. Check all multiplier ranges with the frequency dials, blah, 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 blah. Should be all fine. Okay, great. So, let's see here. We'll put it right on 10. 10 looks good. 10, 10. Yeah, this one's a little bit off. Hey, this thing's only supposed to be good to 5%, so I think we're good. Set the multiplier, adjust the triangle amplitude. Okay. Set the multiplier to 10 to the 4th. It is. Frequency dial to 1. All right, function to triangle. All right. Amplitude fully clockwise, and the function switch to triangle, connect it to blah, 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 blah. Adjust it for exactly 10 volt peak to peak. Okay, and we are actually right there. No, wait a minute. 1, 2, 3. Oh, no, we're 6 volt peak to peak. That's not very good. 1, 2, 3, yeah, 1, 2.5. Oh, 5 volt. Yeah, this is not good. Install 50 ohm between the cable and check to see. Oh, I see. Ah, you do it without the 50 ohm load to get a 10. Okay, that makes sense. That makes sense. All right. And it is 2, 4, 5, plus it's plus minus 5 volts right now, not plus minus 10. 10 volt peak, oh, peak to peak 10. Yes, it is peak to peak 10, because it's plus minus 5. Okay, so that's in spec already, so we won't worry about that one. Adjust the sine wave low frequency amplitude, set the function, remove the 50 ohm load. All right, we'll go to sine waves. Adjust sine wave amp for exactly 5, for exactly 10. It's just a smidgen low, is it? 1, 2. I can read peak to peak actually. Measure. Add vertical peak to peak. Okay. Yeah, 10.2. Adjust 450. Where's 450? Sine wave, symmetry, sine drive, 450 sine wave amplitude. Yeah, I think we're good to go. I think that's only on the older model. Adjust the square wave amplitude. Put it on square wave. Bang. Same thing. It's in spec. It is in spec. All right. Adjust square wave compensation. Connect it to oscilloscope through a 50 ohm cable, a 10 times attenuator, and a 50 ohm termination. Why do you need a 10 times termination? That doesn't make any sense. Oh, we'll just put it in here. Let's check it out. Set the vertical deflection, blah, blah, blah. DC balance of the output waveform is centered around the 0 volts. It looks good to me, so no need for adjustment. Adjust gate baseline. Connect the square wave again to the gate. Sine wave and frequency adjust to the position of the baseline exactly halfway between the positive and negative peaks. Yeah, we're fine. Fine, fine, fine. Okay, we're done. Although, there we go. It's all calibrated. Put it on 3 and it's measuring 30.4. Put it on 5 and it's measuring 5.6. Yeah, it's definitely within its calibration range. Square waves work, sine waves work, triangles work, everything's nice and roundy. Adjusted the distortion. Yeah, everything's looking good. Got plenty of amplitude. This is a cal knob, so when you're setting frequencies, you can set a frequency and then you can adjust this. And if this is getting hard to adjust, you can always tweak it down here and you can fine tune it. So if it's just a little bit off 4 and you have it set to 4, you can adjust this just a little bit and you can put it right exactly at 4, and then it should work from there for a local calibration. So that's what this is for. But normally turn it all the way clockwise to be in the cal position. For the offset, you pull it, and then you can wiggle things up and down. Amplitude is here. This adjusts which one you want. Looks good. It's a nice little generator, and it's 10 times faster than the one I've got. I have an FG501. This is the FG502.